Hello everyone, my name is Shivam Salve and in this video I will be presenting my AI project titled AI Research Paper Summarizer, a multilingual RAG framework for intelligent academic paper analysis. This project was developed as a part of my term project for trimester 9 and this focuses on helping researchers, students and professionals to understand research paper much more efficiently using artificial intelligence. Now let's move to the next slide. Before building the solution, let's first understand the problem. Today, thousands of research papers are published every day across different domains. Researchers spend several hours reading a single paper just to understand the methodology, contributions, limitations, and conclusions. Existing AI tools have several limitations. First, they may generate hallucinated answer because they are not always grounded in the uploaded document. Second, many popular tools require internet connectivity and paid subscriptions. Third, most existing systems provide only one or two features such as summarization without offering methodology extraction, multilingual support, citation generation, or report generation in one platform. These challenges motivated the development of a fully local AI powered research paper analysis system. The primary objective of this project is to create a complete research paper analysis platform. The system begins by extracting text and metadata and from uploaded PDF files using PYMU PDF. The extracted text is semantically divided into chunks, converted into embeddings, and stored inside a FAISS vector database. A RAG pipeline retrieves only the most relevant information before passing it to Gemma2 language model. In addition to question answering, the system can generate executive summaries, explain methodologies, identify contribution and limitations, suggest future work, extract keywords, translate summaries into multiple languages, generate citations, and produce downloadable PDF report. Now let's have a look at our technology stack. The user interface is built using Streamlit. PDF text extraction is handled by PYMU PDF. LangChain is used for recursive text chunking. Semantic embeddings are generated using BAAI BGE embedding models. FAISS acts as vector database for similarity search, which is developed by Facebook, known as now Meta. Ollama provides a local runtime for Gemma2 is to 9 billion parameter language model. Finally, Report Lab is used to generate professional PDF reports. Now let us have a deep look at our system architecture of this project. The workflow starts when a user uploads a research paper in PDF format. The PDF processor extracts both research paper in PDF format, metadata, and textual content. The extracted text is divided into smaller overlapping chunks. Each chunk is converted into a dense semantic embedding using sentence transformer model. These embeddings are indexed and stored inside the FAISS vector database. Whenever the user requests a summary or asks a questions, the query is also converted into an embedding. FAISS retrieves the most relevant document chunks. These retrieved chunks are then passed to Gemma2 through Ollama. Finally, Gemma2 generates context-aware responses that are displayed in Streamlit interface. This RAG approach significantly reduces the hallucinations because the LLM receives only relevant context rather than relying entirely on pre-trained knowledge. Now let us look how the RAG pipeline works. First, the uploaded document is divided into semantic chunks. Second, each chunk is transformed into numerical embedding vectors. Third, all embeddings are stored in FAISS vector database. When a user submits a question, that question is converted into an embedding as well. FAISS performs cosine similarity search to retrieve the top k most relevant chunks. Only these retrieved chunks are sent to Gemma2. Because the model generates answer based on retrieved document content, the responses remain grounded in uploaded research paper, greatly improving factual accuracy and reducing hallucinations. So now here we will go with our project demonstration of the application which we have built. So we are here at our project folder, AI research paper summarizer. So this is the backend structure of this project. It is divided into backend. So this is a py.pym. This is the screenshots of the projects. So these were the tests conducted during the formation of this project. So it contains UIs. For the front end structure, we have used the UIs and which have been separated into different files such as chat tab, chat, citation, future works. Let us look at the backend of this project. So the backend, there is we have the files known as chunkers, citations, embeddings, LLM, uh, PDF processors, prompts, RAG. So let us have a look at LLM. So in LLM where we have taken the Gamma 2 is to 9B model through locally through Ollama. So this is the code which have been, this is the code where we request the LLM, then LLM generic LLM generation, then question agenting, and so on. In citations we have this code where uh, whenever we upload the PDF, if we want the citations, so this is the code for citations. This is the RAG pipeline where file where we are explaining created build vector database, retrieve relevant chunks whichever is required. So this is a generic AI generation code, chat, executive summary, and etc. This is a report generator code where we want we generate the report for this project. So now let's look at the, now we will run this project. This is the command which we are running, a Streamlit run app.py. So this is the app.py running. It takes few minutes to load the dashboard, and not few minutes, a few seconds. So here we got our home page of this AI research paper summarizer. So here this is the our dashboard or home page, we can say. This is our upload research paper section where we will now run the demonstration of this project step by step, and these are the features which we will be getting on our um, this model. So this is automatic PDF extraction, chat with your research paper. We have integrated the chat feature where we can interact with our research paper, executive summary generation, methodology explanations, and so on. We will see that. So and and the most important thing is that a multilingual summary translation. So if a reader is unable to understand the English or any language, so whatever the summary of that research paper, she can he or she can get in his own in their own mother tongue language. So in multilingual summary translation, we have regional languages also and some international languages also, means foreign languages also. So now let us run the uh, this is the sample research paper which have been already created for testing this. Now I have uploaded the paper. Now this is extracting the information from this research paper. Research paper processed successfully. So now here it shows us the page 5 words and chunks it is divided into, and the model we are using Gemma2. So this is the paper information. Here shows title, author and pages paper information. Now uh, the summary, methodology, these are the sections where whatever we want. If we don't want summary, so we can't if we can skip this. If you only want methodology, you can generate the methodology. If you want only contributions of this paper, you can extract. These are the steps which have been given, or the cards. This is the multilingual. For to enable this option, first we need to generate the English summary first of this through this generating summary. This is the AI chat to chat with a research paper, keywords, citations. So let's go with the chat with research paper. Uh, what is this paper about? So by asking AI. I think we got the error. So let's rerun this paper again. It sometimes takes the loading time is exact. It takes some time. So I think this is the issue. Now we will rerun this paper. Research paper processed successfully. GeoGuard AI. This is all right. Now we will click on methodology. Let's check if it is giving or not. So here we got the methodology of this paper which we have used for which we have uploaded. So here we got the objective, we detect damaged buildings, design a disaster assessment, the model use, data sets, workflow, training process, evaluation metrics of this project. So now we will go step by step ahead for this project. So first we will generate the summary. As soon as we have done with this methodology, contribution, limitation, so here we get the AI features which we have used or we have gone through. Why this has been included here? Because at the end when a user want to generate the report, so whatever here is user have gone through, he can generate a report of that thing. So here we got the executive summary of this. After this we have generated summary. Now methodology. Now going to contributions, key contributions. So these are the key contributions which have been found in this. So now going ahead with limitations. So these are the limitations: processing speed, deployment scope. We have done with limitations. Now going ahead with future work. Let's see what the future work of the has been described in this paper. So deployment platform implement add temporal analysis, integrate temporal analysis for pre and post disaster comparisons in this project, which have been in this paper. So this is the future work. Now moving for the keywords. Let's see, extract the keywords. So these are the keywords which we have been extracted from the uploaded PDF. Now going for citations, here is the option which type of citations we want. If we want beep text, so there is this citation it gives. Then IEEE it generates that this citations. So this is the citation which works. Now let's take two prime features of this model. One is multilingual and second is chat with AI. So multilingual summary, for example, if I select, this is the drop down where we have, these are the languages: Hindi, Marathi, Tamil, Telugu, Kannada, Malayalam, Gujarati, Bengali, Punjabi, Urdu, and these are the foreign languages which have been included: French, German, Spanish, Japanese, and Chinese. So now I'm going to run this for an multilingual summary, convert this into Hindi. So this is where we have got our summary got translated into our language, Hindi language, which we have. So here it says यह शोध पत्र जियो गार्ड एआई प्रस्तुत करता है कि एक ऐसा सिस्टम जिससे उपग्रह चित्रों में भवन क्षति means damage of buildings, and this is all. So this is the translation we got in Hindi. Now let's run any foreign language. So let's run German. So here we got the translated summary in German language. So here we done with multilingual. Now the last our chat with research paper is remaining. So what this paper about? Now we are going to ask the AI. So the answer we got: this paper describes a disaster assessment engine that uses a model to detect building damage from satellite imagery. This highlight the system's ability. So this is the which we have got. We have done with our features and extraction and whatever. Now the last feature is, this was the last feature, the chat with AI research paper. You can ask your question related to research paper and it will give you the answer. So these are the features we have done. Now we will generate the report, generate AI report. Here report is generated, so we can click on download report. So report is downloaded. So this is the report which have been given. So AI research paper analysis report, the executive summary, methodology, key contributions, limitations, future works, keyword, and etc. So we have done with our project explanation on demonstration. So let's move back to our presentation. So we have done with our project demonstration. Let's move to the next slide. So 9 AI power features which we have seen in our application running through was executive summary, methodology explanation, key contributions, limitations, future work, keyword extraction, chat with paper, multilingual translation, citation generate. So now let's move to the next slide. Results and evaluation. The system was evaluated using GeoGuard AI research paper. During testing, the uploaded document contained 5 pages with approximately 2557 extracted words, which were divided into 24 semantic chunks. All implemented modules functioned successfully. Executive summaries were accurate and concise. The chat module produced context grounded response. Translation preserved the original meaning. Citation generation worked correctly. The report generator successfully created professional PDF report. This result demonstrates that the purpose RAG framework effectively supports intelligent research paper analysis. Now let's look the comparison. Compared to existing tools such as ChatGPT, Notebook LM, SciSpace, and Semantic Scholar, the Purpose system combines multiple AI capabilities within a single local application. It provides multilingual support, AI-generated reports, citation generation, semantic retrieval, and privacy-preserving local execution. The current limitation is that it processes one research paper at a time, but the modular architecture follows the future expansion. Now let's look at the future scope of this project. There are several opportunities to enhance this project. Future version can support multi-document comparison, knowledge graph generation, citation network, improved OCR for scanned document, GPU accelerated inference, integration with institutional digital libraries, and multi-model analysis for figures, tables, and equations. These improvements would further strengthen the platform as comprehensive AI research assistant. At the last, I would like to say thank you for watching my presentation. I hope this demonstration has provided a clear understanding of how RAG can be applied to intelligent academic paper analysis. The complete source code is available on my GitHub repository, and I welcome your feedback and suggestions. Thank you very much for watching this video.